Now, we did an exercise. We said, what if, this was back in 2006, we implemented a policy to double the rate of tree planting in the urban area, that would be a big increase in the rate of tree planting. And so you can see here in green the biomass, that's just the mass of trees over time, and in red, the number of trees. So if you start doubling the rate of tree planting, you see the number of trees going up, and you see the biomass going up. And the dotted line here is the business as usual scenario, and the solid line is the doubling of the trees. So you see a big difference here in how many trees you end up with and how much biomass you end up with if you double tree planting. But in terms of total CO2 emissions, the black line and the dotted line are right on top of each other. You can't even see the impact of tree planting on total CO2 emissions because at the end of a 50-year period, all of that tree planting only offset urban CO2 emissions by about 0.2%. That's it. So really, trees not having a big effect on total CO2 emissions. And we did this calculation for LA County. Now, actually, I want to say this. These calculations are difficult to do because if you wanted to find out how much CO2 was emitted by the city of Irvine this year, you would not be able to find that data. It is not publicly available. CO2 emissions data are available on a statewide basis, and a lot of the data that goes into those calculations are proprietary. They're owned by the utilities and by other organizations. So scientists have not had a lot of information about how much CO2 individual cities emit. I know that sounds counterintuitive, but we didn't have access to the data. So there was an undergraduate student here at UC Irvine who actually put this together, where she collected data for LA County on lots of things. How much energy, how much food went into LA County, how much stuff came out, how much pollution came out, how much water came out. And for CO2, she came up with this number for the CO2 emissions of LA County, and you can cover LA County in a giant forest and you would not make a dent in this number. There's just no way to do it. So the point here is just this, okay? I don't want to give people the impression that I'm saying we shouldn't plant trees. But what I'm saying is that we do have to do some scientific analyses of these claims of how certain activities can impact the environment. Because if tree planting cannot substantially offset CO2 emissions, then the types of trees we plant, where we plant them, and how we manage them might be different, okay, from what people are doing. And the rest of my talk is going to be about that. So if, carbon is carbon. You can plant a tree anywhere and it will store carbon. If carbon isn't the big environmental impact of trees, what should we do? Where should we put them and which one should we choose? Okay, so now we have to move on to some other impacts of ecosystems on the environment, because most ecologists, I have to tell you that ecologists love to measure carbon, and it's a long story as to why. But normally in natural ecosystems, ecologists spend a lot of time quantifying carbon dynamics, and carbon dynamics are very important from a scientific perspective. But in urban ecosystems, that is not the major impact of your backyard on the climate. The major impacts are all here in these other areas. So I want to talk now about nitrous oxide, because it's something that people don't know as much about. Now I do have to go into the background here. Okay, nitrous oxide is part of the ecosystem nitrogen cycle. So nitrous oxide comes out of soils when microbes in the soil process nitrogen. Nitrogen comes in many forms. So if you put fertilizer on your landscape at home, you're going to end up with ammonium in the soil. Actually, no matter what type of fertilizer you use, you're probably going to end up with ammonium. But inorganic fertilizer is the biggest culprit, because inorganic fertilizer is made up of ammonium. It's actually, there's an industrial process that takes atmospheric nitrogen and converts it to ammonium. And so this ammonium gets processed by microbes. Organisms on Earth need nitrogen. Proteins are made of nitrogen. Amino acids are made of nitrogen. Your DNA is made of nitrogen. Yet nitrogen is very scarce in geologic material on Earth. It's all locked up in the atmosphere. So all organisms are dying to get nitrogen. On land, most ecosystems are nitrogen limited. And when you put fertilizer on your ecosystem, well, you know what happens. Your plants grow more, right? Well, microbes grow more too. And microbes convert ammonium to nitrate, different form of inorganic nitrogen. And in doing so, some nitrous oxide leaks out of that microbial process, which is called nitrification. Then There are different microbes that process nitrate. They engage in a process called denitrification, and it converts nitrate directly to nitrous oxide. Also 2N2, but some of it goes into nitrous oxide. So when you fertilize your soils, it is quite likely that nitrous oxide comes out. And a lot of people have made measurements in agricultural systems on how much nitrous oxide comes out of soil. This is the global N2O budget. So this is where all of the human-caused human sources of nitrogen come from, the anthropogenic sources. And you can see that some of them come from pollution in the atmosphere. There's some that comes from fossil fuel combustion. Some come from artificial human-created ecosystems. Most of it comes from fertilized agriculture, actually, because of all of that fertilizer that we put on the soil.